Okay, so for our next example, we have this limit. So the question is evaluate the limit. Evaluate the limit. I have to see, it's possible that the limit exists or the limit does not exist. So here, what do we have here? Because of the modulus, we know to say we have the positive version of this and the negative version of that. Trying to see if there's something I remember about that treatment. If there's not, I'll still try to use something else. Okay, so can I try to approach via different routes? Let me try. So since it seems like simplification here will not really be straightforward because there are two versions when the denominator is negative and when it is positive, simplification might not be that ideal here. So how about I try to show that maybe the limit doesn't exist? Let's see if that is possible. So I'll try a few routes. If I'll not be able to do that, then I'll say the limit exists, but I just I'm struggling to get to see how it does exist. So let me try along the path y is equals to x. If I tried along the line y is equals to x, then I have the limit x comma y, because for that part now I'm saying x and y are the same. So I have this approaching 0, 0. So it's basically just like I'm dealing with just x. So I have x over x. So that now I have x squared, x approaching 0, x squared. So you see, I still have that problem of a 0 being present. And that is going to be very tricky to get rid of. So I still have that x there being squared. But of course, now I have the modulus. But the fact that this is going to be squared, there's no need for me to maintain the modulus. It's going to be x approaching 0. And now I'm going to have just x squared over x squared. And this is going to be 1. Do you see that? Have you seen that?
No.
Okay. What have I left to?
So when you remove the what absolute value.
Okay. So this is x squared. The absolute value just means that if the argument here gets to be negative, I should make it positive. But it's x squared. If x is negative, the square will show that it will still be positive. Do you agree?
Yes.
So this implies that this modulus of x squared is actually the same as x squared. The two always have the same value. No need for me to maintain the modulus now. Right?
Yes. So for example, if it was power 3.
No, that would not work. Power 3 allows negatives to come out. I would have to maintain the modulus.
Right.
So now, what if I approached along the line y is equals to negative x? Remember, if it's possible that the limit exists, regardless of the path I use, I should get the same thing. Now I'm approaching along y is equals to negative x. So meaning that now I'm dealing with x approaching 0, but now where there is y, I'm putting negative x. So I will have x, there is y there, I'll put negative x. In the denominator, I have the modulus of x, and if there is y here, I'll put negative x. So now this will be the limit as x approaches 0, but now when I multiply this and this, I'll get negative x squared. In the denominator, I'll get the modulus of negative x squared as well. But what will the modulus here? The modulus will make this, will still tell us just ignore the negative. X approaching 0 of minus x squared over x squared. Do you agree?
Yes.
So here now, this cancels, leaving the answer as negative 1. Do you agree?
Yes.
So what conclusion do we make? The limit does not exist.
Does not exist.
Because when we approach using one route, it's telling us the limit is 1. When we approach using the other route, we're getting the limit as -1. We can't get different things. So here, no debate, the limit does not exist. This was interesting.